This is problem number 10 from section 4.5. In this problem it says solve the polynomial equation, and they give you a fourth degree polynomial, but it's separated by an equal sign, like parts on the left, parts on the right. We need to get it set equal to 0. So first step I'm going to take is I'm going to start moving these factors to the left. So I'm going to add 2x squared, that's x to the fourth, plus 4x cubed, plus 2x squared equals 35 minus 28x. Now I'm going to add 28x to each side, and that's going to give you x to the fourth plus 4x cubed plus 2x squared plus 28x equals 35. Then I'll subtract the 35 over, so minus 35 on each side. I get x to the fourth plus 4x cubed plus 2x squared plus 28x minus 35 equals 0. Now, because this is a fourth degree polynomial and there's 5 terms in it, we can't really do factor by grouping. We don't know any zeros. So I'm thinking the only thing we can do here is the rational zeros test. So remember the rational zeros test, we're going to take this Q value, or sorry, these are the P values, and we're going to write them out at the top. So P, which is negative 35, all the factors are negative 35, so that's just plus and minus 1, plus and minus 7, plus and minus 5 for the factors of for P, factors of negative 35. Now the leading coefficient's 1, so they're being nice to us. Q is 1, and that factor is just plus and minus 1. So then we need to figure out all the different combinations of P over Q. So P over Q, well, that's going to be obviously 1 over 1, which is plus and minus 1. 5 over 1, which is plus and minus 5. And 7 over 1, which is plus and minus 7. So what I'm going to do is I'm going to start taking these numbers and plugging them into this equation here. Use your calculator to do this, and we're going to find some zeros here. And we're trying to find, obviously, these are the real zeros. So we're hoping that there are some real zeros. So we're going to say 1, store it as x. And we're going to say x to the fourth plus 4x cubed plus 2x squared plus 28x minus 35. Hit enter. I got 0. So 1, holy smokes, 1 plus 1, positive 1, is one of our zeros. So I'm just going to kind of write out zeros right here. 1. 1 is one of them. So now I'm going to try and do negative 1. So negative 1 stored as x. And go up and grab that equation. Hit enter. Okay, negative 1 does not work. So I'm going to kind of cross out negative 1. Now we're going to do positive 5. So 5 stored as x. Hit enter, grab that function, not 5. So 5 doesn't work. Now let's try negative 5. Store it as x, grab the function. Yes, negative 5 is a 0. We got 0, so negative 5 is a 0. So it works. So I've done these ones now. All right, and the only one that didn't work was the positive 5 version of that. And then plus and minus 7. So let's go 7 stored as x. Grab the function. Doesn't work. Negative 7 stored as x. Grab the function. It doesn't work. So none of the 7s work either. So only ones out of the 6 combinations that we had there were 1 and -5 that are real zeros. So if we have 2 real zeros and we have a degree 4 polynomial, how many imaginary zeros do we have? Well, we got to have 2 imaginary zeros that come in pairs. So if these are the zeros, let's write out what the factors are. Remember, x minus k, so I'm going to do x minus 1 is a factor, and x minus -5 is a factor, which is x plus 5. Now, I'm going to multiply these together so I can do some long division here, and then we'll find out the other factor that we can basically set equal to 0, probably use the quadratic equation or something to find the other 2 zeros. So, x times x, x squared. X times 5, 5x. -1 times x, -1x. -1 times 5, -5. So we get an x squared plus 4x minus 5. So I'm going to use this now to do some long division with this long equation here. So we're going to say x squared plus 4x minus 5. We're dividing x to the 4th plus 4x cubed plus 2x squared plus 28x minus 35. X squared goes into x to the 4th, x squared times. Multiply it through, that's x to the 4th, plus 4x cubed. X squared times this is -5x squared. We're going to subtract, and remember I like to distribute the negative, so that's -x to the 4th minus 4x cubed plus 5x squared. Cross it out, start combining these. This is 0, this is 0, this gives you 7x squared. Bring down the 28x minus 35. How many times is x squared going to 7x squared? Well, it goes in there 7 times, so we say plus 7. 7 times 7x squared is 7x squared. 7 times 4x, we get 28x. 7 times -5, we get -35. And holy smokes, look what happens. We subtract, distribute that negative. I'm not even going to do it here because you can see when I subtract them, they all cancel out and I get 0. So our other factor is x squared plus 7. So we could actually even write this. This is x squared plus 4x minus 5 times x squared plus 7. This is actually this function here. Right? They're the same. So this is the same as this function here. Now I already have this part solved, right? The zeros that I get from this side are 1 and -5. So what I want to do is I want to take x squared plus 7 and set it equal to 0. Subtract the 7, I get x squared equals -7. Take the root of each side, so root x squared equals root -7. This will give you x. Root of -7, root of a negative is going to give you an I, so we'll end up with plus and minus I root 7. So what are all the zeros? All the zeros are 1, -5, I root 7, and -I root 7. So we have 4 zeros, 2 of them real, 2 of them imaginary, and those are our solutions right there. Hope that makes sense.